So starting with the parent graph, y equals tangent of x, to find an inverse, we switch the x and the y. So let's go ahead and graph x equals the tangent of y. And we can see that those green curves that are x equals tangent of y, they fail the vertical line test, right? Tangent was a function because it passed the vertical line test. Its inverse that we found by switching the x and y fails the vertical line test, so that is not a function. Now, if I graph y equals arctangent of x, there we can see in the middle, that's the only curve that is part of the arctangent when it is a function. So all of these others here, those disappear because those are the curves that were causing the graph to fail the vertical line test, and we need arctangent to be a function. So the arctangent is restricted between negative pi over 2 and positive pi over 2 with respect to its range. Its domain is fully unbounded, but these horizontal asymptotes at negative pi over 2 and positive pi over 2 are trapping that arctangent curve within that restricted range. From 0 to pi over 2, that's quadrant 1, where tangent is positive. From 0 to negative pi over 2, that's quadrant 4, where tangent is negative. So the principal values for arctangent are in quadrants 1 and 4. So on the front of your notes booklet, we'll summarize that information for the graph of the arctangent function. Its domain is fully unbounded from negative infinity to positive infinity, and the range is non-inclusive, right? So we have parentheses instead of brackets because negative pi over 2 and positive pi over 2 are asymptotes, and the graph is going to go between but not touch or cross those horizontal asymptotes. And our principal values in quadrant 1, that's going from 0 to this asymptote at pi over 2, those are positive principal values. And then from 0 to negative pi over 2, that's quadrant 4 on the unit circle, and those are negative principal values. So let's go ahead and apply these principal values to some examples. In example 3a, we're asked to evaluate the arctangent of negative square root of 3 over 3 for all angles in degrees. So recall our acronym, all students take calculus, and the tangent is negative in quadrants 2 and 4. So we're going to have a solution here in quadrant 2, and then another solution here in quadrant 4. Okay, our first quadrant reference angle is the angle that has a ratio of y over x with its coordinates that equals positive in quadrant 1 root 3 over 3, and that would be pi over 6 radians or 30 degrees. And if we reflect 30 degrees into quadrant 2, then we're going to be starting at half the circle, which is 180, and subtracting, going into the negative direction clockwise to get 150, because 180 minus 30 is 150. Then to get into quadrant 4, we're going to be starting at 360, which is one full revolution around the circle, and going backwards or clockwise, we subtract to get 330 degrees in quadrant 4. Now, the principal value is a quadrant 4 angle, but the principal value is negative in quadrant 4 because our interval, remember, is going from negative pi over 2 to positive pi over 2. So the principal value is negative 30 degrees. And then when we go to represent our angles, for all angles in degrees for which the arctangent is negative root 3 over 3, we find the first positive or non-negative angle, which is 150 degrees. That's our quadrant 2 angle. And then that's plus or minus k times the period of tangent, which is 180 degrees. So if I start at 150 and I add 180, see how I get to 330. And then 330 plus or minus another 180 would always take me back to a coterminal angle with 150 degrees. So this would be the expression representing all angles in degrees for which the arctan is negative root 3 over 3. Okay, next we're going to solve this equation. 3 tangent of x minus 4 equals 1. And we're going to start by adding 4 to both sides because we're trying to get that tangent of x by itself. So now we have 3 tangent of x is equal to 5. And then we'll divide both sides by this coefficient of 3. And now our tangent function is isolated. Tangent of x is equal to 5/3. And to undo a tangent, we need an arctangent. So x is equal to the arctangent of positive 5/3, which means my principal value is going to come from quadrant 1. So if I'm starting here at 0, this is pi over 2, pi, 3 pi over 2 would be down here at the bottom. And I'm going to put in my calculator, working in radian mode, which I'm in radian mode, the arctangent of 5/3, which is approximately 1.03, rounding to 2 decimal places. And pi over 2 is about 1.57, right? So we can see that we're going to be pretty close to pi over 4 here with this quadrant 1 solution. And that is my principal value. So principal value is approximately 1.03, and that's within my interval for my solutions, 0 to 2 pi inclusive. So 1.03 will be my solution from quadrant 1. Now to find my quadrant 3 solution, because tangent is also positive in quadrant 3, then I'm starting at pi, and I'm going to add my principal value because I want to rotate counterclockwise into quadrant 3. So I'll have pi plus 1.03 which is approximately 4.17. And that would be my quadrant 3 solution. So to check these answers, we're going to substitute them each one at a time in for the x. So we'll start with the principal value, 1.03, and we get 0.9957, which rounds to 1, right? I expect that not to be exact because I used a rounded decimal as my x when I substituted. Now we'll check the quadrant 3 angle, 4.17. And again, our answer rounds to 1. It's not going to be exactly 1 because we used a rounded decimal when we substituted, but we can see that both of these solutions, 1.03 and 4.17, check.